Hello. Hello.
Hello, sir.
Hello,
Yes,
Doc.
so I think we can start.
Okay.
So last week we started looking at the meaning of quantitative method, of which we said that it is the use of mathematical and then statistical models to analyze complex business problems so that we can simplify them for decision making. We went ahead to look at some of the models or the tools of quantitative method we mentioned pertaining to differentiation, integration, correlation, regression, time value of money, and the rest. Then later we came to look at some of the uses of quantitative method, which we said basically we can use it for the planning purposes, organizing, and then making budgetary controls, as well as we being able to monitor our progress as a business. From there, we zoom into data and how we can present data. Of course, we explain data to be that raw facts or numbers, as well as once we process this raw fact, it becomes an information. And we went ahead to look at the various types of data, ranging from the broader category, where we looked at the quantitative data and qualitative data. We explain qualitative data to be that data type that is mainly described using words. And we also mentioned that quantitative is the data type that we can use numbers to naturally describe certain phenomena. From that broader perspective, we moved into looking at the various levels of data measurement, where we looked at the nominal scale, the ordinal, the interval, and then the ratio. For this, we mentioned that the nominal is where we're talking about the qualitative data that can only be kept into categories. So that is the basic form of data description. And with that particular data, the only thing we can do is to put them into various categories. And they are also qualitative in nature. We moved on to ordinal, and then we mentioned that for ordinal data, they are also qualitative as well as putting them into categories. However, we can see some natural order in the various categories that we are able to put the data into. And so ordinal data moves a step ahead of the nominal, where we can now have a natural order within the various categories of data that we have. We mentioned some few examples, and then we moved on to the interval data as well as the ratio. We mentioned that the interval is similar to that of the ordinal. However, for interval, we're looking at that scale of data measurement, which is mainly quantitative. So when it is numerical, and then we can still have that natural flow of order, then we can say that it is interval. And then comparing the interval and the ratio, we also established that interval usually consider those quantitative data where when you have zero, it doesn't truly represent the nature of a zero. Hence, we concluded that interval do not have a natural zero. Whilst ratio, when you have zero, it communicates the intent of zero. And so ratio has a natural zero. Then from this category, we also realize that data can also be in the form of primary and then the secondary. So we discussed some of the primary data to also mean that the data that we get on the foot for the very first time. So the first hand data that we have or we collect is a primary data, as well as the secondary data becomes the data that has already been collected, and we being able to process and store them in the form of another data. That becomes the secondary. We mentioned some sources or how we even collect these data. So primary, we said that we can use observation. We mentioned questionnaire. We talked about interview, experiment, and the rest, all being the various ways or sources of getting these primary data. And then the secondary too, we realize that it can also come in the form of magazines, books, as well as online data sources. For example, when you go to the Ghana Statistical Service data source online, you will realize that it will have some range of data that are available. And these data were collected during their various census as well as surveys that they have. And so they collect the primary, process into a semi-finished data, and then store them online for further usage. And so these were the various types of data that we discussed last week. From there, we looked at how we can present these various data. Because of sometimes the volume of the data, it is ideal that we have a way to present these data so that using these data do not become a challenge. And so we discussed that data can be presented, one, using graphical methods. And then the graphical methods, we started talking about the bar charts, where we said that bar chart is usually used to store qualitative data in the form of bars or on a graph. And this graph is having bars of equal width. However, the bars are separated from one another using the class limit. And so I recall that I was stressing on the fact that for bar chart, we're going to plot the frequencies of the data as against the class limit. And it is usually used for the qualitative data. Then from the bar chart, we moved on to the pie charts. And then the pie chart also, we're trying to now represent the entire data on or dividing a circle into various segments that will each represent a particular set of data within the entire data set. So once we represent the data in the form of a circle, then we are now looking at a pie chart. And so we also looked at how we can now convert each segment or each item of the data into a part of the circle, where we introduce the formula 360 times n over f. 360 times f over n rather. And we established that the f is looking at the frequency of each item in the question, whereas the n is looking at the summation of the frequencies. So each item's frequency divided by the total frequency times 360 degrees. Because a circle has a circumference of 360. We do that and then we are able to segregate it or divide the circle appropriately using our protractor as well as our compass. Then from there, we came to histogram. There we established that histogram is similar to that of the bar charts in terms of how they look. We're using bars to represent a given set of data on a graph. However, when you talk about histogram, it is used to represent quantitative data, whilst bar chart is used to represent qualitative data. Again, we realize that for histogram, we're going to have continuous bars, whereas our bar chart, we're having separate bars. And so that is what we have to take home, the two distinct features. And then the last one is that for histogram, we are going to plot the frequencies as against the class boundary. And then the bar chart, we are going to plot our frequencies as against our class limits. I recall illustrating to you last week how we can even convert class limits to class boundaries so that they become a continuous data set. So that is where we ended last week. And if there is any question or a clarification or any addition, we can put it in now before we move into what we're supposed to do today. Is there any addition? Was there any challenge? How far with the assignment? Some of you have started. Some sent me their questionnaire items. How far? Let me hear you. Hello.
Please, Doc, how should we send the assignment?
Come again.
Please, how do we send the assignment to you?
Yes, so I'll communicate when you are going to do that. But I want to find out how is going. How is it going?
Okay,
Hello.
I'm also done with it, but I don't know how.
Okay, so what I want you guys to do is that I want you to use the Google form. I realize that most of you were having the paper questionnaire where you have it on your Word document. I want you to learn how to use the Google form to create the questionnaire. So I don't know if that is what you have done. Once you are done, I will communicate to you through your rep after the class on how you should submit the assignment. Is that okay?
Yes, sir.
Yes, sir.
All right. So any concern addition so far before we continue? Or we can move on.
Yes, please.
Yes, sir.
So from the histogram, there are some illustrations with the slides as I shared with you, so you can go through them and see how we can go about it. Now let's look at frequency polygon. Now, unlike the histogram as well as the bar charts, when we have the frequency polygon here, we are going to be interested in the class midpoint. Class midpoint, and we're going to plot the midpoint as against the frequencies, so that here we're going to have a display of a graph that is having the coordinate of the midpoint and the frequencies, and then we plot them accordingly. So it means that whenever you're given any question that is requiring you to do the frequency polygon, we trying to just get the class midpoint from this illustration. For example, you have to calculate the class midpoint. And how do we calculate the class midpoint? We're going to add the lower limit to the upper limit and divide it by 2. Or we add the lower boundary to the upper boundary and we divide it by 2. Whichever approach that you use, the answers are going to be the same. So for you to get the class midpoint from this illustration, first, we're going to add our 100 to our 104 and divide it by 2. And the answer is going to be 102. So the first row is going to be 102. Then the next one is going to be the 105 plus 109 divided by 2, which is going to give us 107. So we do that in that particular order. Once we get a class midpoint, then our plotting is going to be the class midpoint on our horizontal axis, and then we have our frequency on our vertical axis. Then we draw our scale appropriately. Then once we have the scale, we're going to plot the coordinates. So this time around, let's assume here is 2, and then here is 8. And then we have 102 in that particular order. So let's assume the first bar on our vertical is 102. We're only interested in the coordinates. So we see where 102 is meeting the 2. Then we draw our points. Then we look at 108 where it is also connecting with the 8. And then we draw that particular point, or we indicate the point on the graph. Then after we connect these respective points as we have. So there is the first one, 102 as against 2. Then we have 104 as against 8 in that particular order. Once you're able to do it, you connect the dots right from how you plotted these items on the graph sheet. Then now this frequency polygon is just aiding us to understand a broader picture that we will be looking at later in this class. So let's move on to the next one. Okay, we have a trial question here. So when we have this one, all that we have to do is to be able to have our values because they are in classes. Then we get our classmate points. Then we have our frequencies here. So this is the table that we're going to create. So we have 0 to 5, 5 to 10, 10 to 15. So which class is these values? Is it in the class boundary or the class limit? And why? Which classes are these values? Anybody to help us with that? Hello. Can you hear me?
Yeah, class midpoints.
No, I'm looking at the values. So when the way the values are presented from 0 to 5, then from 5 to 10, I want to know whether it is class limit or the boundary. I explained this one to you last week. I just want to know whether it went down well. So the values and how they are presented. Do we say they are class limits or class boundaries, and why?
They are class limits because the question has given us a limitation of the age group that from within so from 0 to 5. So those of them who fell within from 0 to 5 are 25, and those who fell within 20 from 5 to 10 are 80. So it's a class limit.
It's a class.
Sir, please, it's a class boundary.
It's a class boundary.
Let him finish. Anthony.
Yes.
Anthony, what was your submission? Boundary or limits?
So for me, yeah, I'll pick limit.
Okay. Then Juliana, you came in.
Yeah, so it's a class boundary.
Why?
Because when you look at the value, 0 to 5, and then from 5 to 10, 10 to 15. So you can see that the boundary you start from one point, then from the same point you go to the other. So that's the class boundary.
Okay.
But with,
Any other?
but with the class, okay. But with the class limits, you see that if it's supposed to be 0 to 5, the next one will be 6 to 10. And then the next one will be 11 to the other. So you see the limits, the first value is different from the second one. Thank you.
Do we agree? Do you have any opposing view?
I agree with Juliana.
I agree there.
Do you agree with who?
I think the boundary, Juliana.
Okay.
An end of a boundary is the beginning of another one. That's how I see it. Yes.
Okay. So Anthony, are you with us now?
Yeah, yeah.
Do you agree with
Yeah.
them?
Oh, yes.
Okay. So there is a class boundary, and these classifications are very important because remember, when you are to do histogram, you need a class boundary, and when you are to do the bar chart, you need the limits. So it doesn't have bearing on this particular question where we're trying to plot the frequency polygon. However, I just wanted you to reflect on that we learned so that whenever you see them within the objective test, you'll be able to answer them. Okay, so once you have the class boundary, I told you that for you to get a class midpoint, you only have to add either the limits or the boundary. So you add in the lower class limit to the upper class limit, or you add in the lower class boundary to the upper class boundary. And then you divide the answer by 2, and that becomes your midpoint. And so 0 plus 5 will still give us 5, divided by 2 is going to give us 2.5. And when we add 5 to 10, that is 15 divided by 2, 7.5. And that is how you get in your class midpoint. Once you have the class midpoint, then you are able to plot the midpoint as against the frequency. So you draw your table, and then this becomes the frequency. So you can have the frequencies ranging from, let's say, 25, let's say 50, 75, in that particular order. And then you get your midpoint to on the horizontal axis, and then you draw the respective points. So once you get the point, you connect the point, and you are able to draw your frequency polygon. Now let's add a little to the frequency polygon to look at the cumulative frequency curve, or what we popularly refer to as the OGAVE. So when you want to plot the cumulative frequency here, there is a very good reason why we will have to advance from the polygon, frequency polygon, to the frequency or the cumulative frequency curve. At this point, we are not just interested in the midpoint, we are also interested in the cumulative frequency. And by cumulative frequency, we are talking about we add in the various frequencies right from the first class to the last class. And so, for instance, when we consider the example we were solving, where we had 0 to 5, 5 to 10, 10 to 15 in that particular order, and their respective frequencies starting from 25, let's say 80, let's say in that particular order. Now, what we are saying here is that as you move along, the cumulative frequency simply means that the addition of the frequencies. So as you move from one class to the next, you are only adding the frequencies of the respective classes that you've been able to move. So that is what we mean by the cumulative frequency. And this is used in statistics and data analysis to understand the distribution of the data. And most importantly, it is going to help us to calculate percentiles as well as quartiles. This one is what we will look at in the next topic. So I will hold it here, but you should always bear in mind that the cumulative frequency curve or the OGAVE help us to know the percentile distribution of the data as well as the quartile distribution of the data. And it is, hello, Mercy. Okay, so it is just helping us to know the distribution of the data. So we are not just representing the data into a curve or on the graph, but we want to understand how the distribution is looking like. For example, can we have a portion of the data representing 20% of the data distribution? Or can we have the first quarter, the second quarter, the third and the fourth quarter of that particular data distribution? And this is how we get it. We normally use the cumulative frequency curve to represent the data on the graph. And once we have the graph sheet, because we are using the cumulative frequency, which add up to the 100%, we can now know the distribution from that particular angle. So these are the steps for constructing the cumulative frequency curve. One, we only have to draw and label our horizontal and vertical axis. And here we represent the cumulative frequencies on our vertical axis. And we either use the class midpoint or the upper class boundary. These points are what you are supposed to take note. So when you want to plot the cumulative frequency curve, you either going to use the upper class boundary or you're going to use the class midpoint. So whichever way that will be appropriate for you, you decide to go by that particular way. And once you label this part, you just plot the cumulative frequency against their respective upper class boundary or class midpoint, similar to that of the frequency polygon that we did. Then you're able to join the points by a smooth curve. Let's try this example and see. Now, given the following data, construct an ogilvy. And remember, for us to be able to construct the ogilvy, we are going to be in need of either the class midpoint or we will need the upper class boundary. So let's assume you are going to use the upper class boundary. The question is, are the marks given in the data in class boundaries? If the answer is yes, then it means that there is no calculation or adjustment to be done. You only pick the upper values as against the cumulative frequency. But if the answer is no, then it means that you have to convert these class limits into the class boundary and then be able to use the upper class boundaries. Or we can equally forgo the class boundary issues and then compute for the class midpoint and then plot the midpoint as against cumulative frequency. So by way of solving this, we can have our marks here. We have the frequency. We just develop the table. And then you can also go for, let's assume you're going for the class midpoint. And at the same time, let's also go for the class boundary. And then we have the cumulative frequency. So this is how it's going to be. You have the 0 to 10. You have 11 to 20. So which class is this one? 21 to 30. Yes. Juliana, you can go ahead.
Yeah, it's class limit.
Yes, so there is a class limit. And the reason is that
the reason is that the marks from one point to the other, the marks are different. So from 0 to 10, and then when you come to the next point is 11 to 20. So it means that we have to change it to class boundary.
we have to change it to class boundary. So how do we change it to class boundary? Who is helping us? Yeah, Mercy.
So we have to deduct a mark from the lower case and add up to the upper one.
Which mark do we deduct and add?
So from the previous one, we have deducted 5 from the lower mark and add up to the one in the higher one.
Was it 5?
0.5.
0.5.
Oh, sorry,
Uh-huh.
0.5.
So we do minus 0.5 plus 0.5. We're going to have negative 0.5 up to 10.5. Then we get 10.5 up to 20.5. Going to have 20.5 up to 30.5. And I hope you can complete the rest. Can we complete it?
Yes, please.
All right. Then let's also complete the class midpoints. What will be the first value? What's going to be the first value for the midpoint? 0 plus 10 divided by 2.
5.
Should be 5.
5.
Followed by
15.5.
15.5. Next,
25.5.
okay, so I know you can complete it now. Now let's look at the cumulative frequency. For the cumulative frequency, we're saying that we're adding on the frequencies as we move through the various classes. So for the first class, its frequency is 2. And because we don't have any other frequency before it, we maintain the 2. But as we move through the second class, we realize that the frequency for the second class is 8. So what we do is that we add the 8 to the latest cumulative frequency of 2, and that is going to give us 10. Then we also move to the next class, which is having the frequency of 12. This time we are adding the 12 to the 10 to give us 22, because we said we adding up the frequencies as we move through. Now the next is 18. So we add the 18 to the 22, and that gives us 40. And then we add the next one, which is 28, to the 40, and we are going to get 68. When we move to the next, we are adding the 22 to the 68, and that is going to give us 90. I hope you are following.
Yes, please.
Then when we get to the next, which is having a frequency of 6, we add the 6 to the 90 to give us a 96. And finally, we add the 4 to the 96 to give us 100. So normally, for the respective cumulative frequencies that we may be seeing in respective examples, the last value of the cumulative frequency is usually representing the summation of all the frequencies. That is when we add all the frequencies together. The last value of our cumulative frequency is supposed to be that exact value when we add all the frequencies. So this is how you develop the table. Now, once the table is developed, we said that the steps, so we should draw and label our X and Y axis. So our X axis is going to be the cumulative frequency. No, the X axis is going to be the class midpoint or the upper class boundary. And then the Y-axis is going to be the cumulative frequency. So once we label it as such, then we can plot it in that particular order. So by solution, we have our class boundaries here, and then we have our cumulative frequencies also here. Then we could have midpoints as well. So assuming we want to plot the upper boundary as against our cumulative frequency, then our graph is going to be like this. We just plot the various points and we connect them with a smooth curve, as we saw in the steps. Any question? Yes, Prince, go ahead.
Please, will you be the scale, or you are just going to look at the cumulative frequency to derive your own scale for the graph?
So for the graph, you have to develop your own scale, as you've mentioned. You just look at the values in the cumulative frequency,
Hello.
as well as the upper boundary or the midpoint. Can you hear me?
Hello, Doc.
Can you hear me? Hello?
Yes, sir. We can hear you.
Yes, so you have to develop your own scale, and then that scale depends on the values you will have in your cumulative frequency, as well as that of your upper boundary or the midpoint. So we know that the graphs are made up of 2 centimeter boxes. So you have to decide whether you're going to choose each centimeter to represent a scale of a 10 or whatever, depending on the values you have in the question. So you have to develop your scale. Any other concern? All right. So this, we relying on the upper class boundary and our cumulative frequency. That gives us okay. So you can try this one on your own as you have the slice. Then we look at the application of the OGIV, where we can see it in the Lorentz curve. So when we talk about the Lorentz curve, it is mainly the application of the OGIV, where we are going to be able to explain how economists are going to rely on the OGIV to know the distribution of income or wealth that is being shared among a particular population. So within economics, you can recall that we can talk about how even income or wealth is shared among population. For example, if you have 3 communities, let's say we have central region, we have western region, and then we have eastern region. And out of these 3 regions, let's assume the population of central is, let's say, 10,000. The population of western is 13,000. Then the population of eastern is 16,000. Now, out of these 3 populations, if we are to share, let's say, an income of 1 million Ghana cedis among these 3, how do we distribute them to bring about even distribution or equal distribution of the income? Now, for us to know whether the distribution, however we do it, is even, then we can rely on the Lorentz curve. And that is how we apply the OGIV. Remember, the OGIV is looking at the cumulative frequency, how we plotting it as against the midpoint. There is a little twist here, because for the Lorentz curve, we are now going to graph the cumulative percentage of the wealth. So the income that we want to distribute, what is the percentage that is going for central? What is the percentage that is going for western? And what is the percentage that is going to eastern? That is what we mean by the cumulative frequency or the cumulative percentage of that particular income. Then we are going to plot that one against the cumulative percentage of the population. So the population also, what is the percentage of 10,000 to the total population? And that will help us to know the percentage of the total population that is given to central region. In other words, we now want to convert all the values into percentages. Then by percentage, we can have a fair analysis of how the distribution is done. So for example, if central region is representing, let's say, 25%, and then Western is representing, let's say, 35%, and then Eastern is representing 40%. In this case, you know that at least the income, all things being equal, 40% of the income should go to Eastern, 35% of the income should go to Western, and then 25% goes to Central. And that is how we can now understand that there is an even distribution. This is so because the amount that we share to each region may be misleading, and that is why the Lorentz curve requires that we use the percentages as against the percentages, and that will show us how even the distribution are. So the main use of the Lorentz curve is to determine the fairness of income distribution among population. The main use, I'm stressing on this because you write objective tests. The main use of the Lorentz curve is to determine the fairness of income distribution among population. Now let's go through the steps in drawing our Lorentz curve. So the steps, one says that convert the population into percentages and rank them using ascending or descending order. So when you are given the raw question, the first step is to convert the population into these percentages. Now, step number 2 says that once you are able to convert the percentages and rank, you are also to convert the income to percentages and write them by their respective percentage population. So the first 2 steps are very important. The first 2 steps are very, very important. So when you miss the first one, already you should know that you are likely to miss the other steps. So step number 3 says that we should accumulate the population percentages to get the cumulative frequency of population. Then we do same for the income or the world in step number 4. Then step number 5 says that convert the population into percentages. Oh, this is step number 1, 2, 3, 4. Step number 5 says that represent the cumulative percentages of population on the x-axis, that of income on the y-axis. Then we plot the cumulative percentages as against the cumulative percentage of the population. So you plot the population as against the what? Or the income, and then you are able to connect them similar to that we saw in the frequency, cumulative frequency. Then the last step says that draw a line of equity. The line of equity. And the line of equity, because already you've converted everything to percentages, you realize that you are going to have values ranging from 0 to 100%. So you just connect, after having the curve, you use your straight edge to connect a straight line from the origin through to where you have in the 100. So let me share a question with you. Then we look at it. Now, this is the first illustration. Let's look at this one has a solution. So let's quickly go to yes. So let's try this one, and then we go through the various steps in solving it. So let one person read the question for us. Then we use the steps that we've earlier indicated to solve it. Then later you can look at what you have in the early slice. Then you can also reflect. So one person should read for us.
The population and wealth distribution of traders in the central region before and after the yield levy are given as follows. Draw a Lorentz curve and comments on the effectiveness of the yield levy. What are the uses of the Lorentz curve? Please, I'm done, or I should read the table. Hello.
Yes, so when you have such information now, from this given example, you are given the population, and then you also have the net worth before tax, and then the net, no, before the introduction of e-levy, and then the net worth after the introduction of e-levy. So one other importance of the Lorentz curve is to help you to assess the effectiveness of a particular policy. So for instance, we had populations as against their income. And now we want to understand how these incomes are affected when we introduce e-levy. And so this is how the question is looking like. Now, the first step says that we should do what? Who remember the first step? Hello, I said we are going to go through the rules.
It says that we should convert the population into percentage and rank them. Yeah.
So we convert the population first into percentages and rank them. So what it means is that you have to find the total population by adding all the values that we have in here. So that's the first thing to do, because you want to find the percentages of this population. So let's add the population values, and then we do the ranking. 3,000 plus 2,500 plus 2,000 plus 1,500 plus 1,000 plus 750 plus 500. Let's find the total. What do we get?
11,250.
11,250. Anybody to confirm? Any confirmation?
Yeah. Yes, sir.
So for us to get a percentage of population, let's work our percentage of population here. We're just going to have 3,000 divided by the 11,250, right? Times 100. And then the next one is going to be 2,500 divided by 11,250 times 100. So let's work out the various percentages. We now want to convert the various populations into percentages. And for us to be able to do that, we have to express each population as a percentage of the total times 100. So for the first one, we will have the 3,000 divided by the total, which is the 11,250 times 100. Any value?
26.7.
26.7.
I got 22.6 and I run into one decimal, please.
Come again.
I got 26.6 and I round into one decimal, please.
You let's make it a whole number and see.
Okay, so 27.
27. Okay.
Well, it's got 26.7.
The next one.
26.6.
The next one will be. I hope you are all working.
Yes, sir.
The next one will be 22.
22. Followed by 2,000 over 11,250 times 100. So let's work it out.
18.
Followed by, I want others to give me figures. So when we are directed by one person, it's not good.
13.
Or I should mention names.
Next one is 9.
9. Okay. Followed by
7.
And the next one is 7.
and the last one.
5.
Okay.
Is 4.
Is it 4 or 5?
4.
4.
Okay. Now let's try and add the. Let's try and add the. Oh. Let's try and add them and see what we get.
It's 100.
100. Okay. So give me the figures again.
27.
27.
22.
22.
18.
18.
13.
13.
9.
9. 7 and 4.
And 4.
Okay. Now let's do same for the net worth before. Now, remember the first step. It says that we should convert the population into what? Percentages. And we rank them using ascending or what? Descending order. Now, you realize that the ones that we've converted, it is already arranged. Because we're having the highest to the least. Can you observe that? The 27 is higher than 22. And so it is already arranged. In exams, you have to watch out because in any case that the arrangement is not following, you have to do the arrangement. And then you can do the arrangement based on highest to the least or the least to the highest. That is very important key to look at because the steps say that we should complete the step number 1 by also arranging after converting the values into percentages. Now let's go to step number 2. Step number 2 says that we should convert the income or the worth also into percentages and we write them according to where the values are in terms of the population. So in this case, we follow the same approach. We find the total what before the e-levy. So we just add the 300, 400, 500 down to the 900. What is the total value? What is the total?
4,200.
4,200.
4,200. So we're going to have 300 divided by 4,200 times 100. We also have 400 divided by 4,200 times 100 in that particular order. So we get to the 900. So some of you should start from the bottom and others should start from the top so that we move faster.
Yeah, 300 is 7.
300 is 7.
$900 is 21.4, so 21.
Which one? The 900? Julie, which one did you mention?
The 900 from the
Okay.
bottom.
All right.
The 400,
Also,
400 is 10.
400 is 10.
Yes.
Okay.
No, 500 is 12.
512.
and 700. 700 is 17.
17.
And it's 16.66, so I round it to 17.
That's fine.
600 is
600 is
14.
14.
Okay. Now it's left with 800.
600 is 19.
19. Okay. Let's try and see if the summation will be 100.
Yes, please, it's 100.
Okay. Let's do same for the net worth after the e-levy. So the same approach, we can have some of you working from the bottom and then the up.
Total 1,700.
Which one? Total 1,000. Okay. So this one, we even have the same value. So one person should work the 250. And then another will do the 200.
The 250 is 15.
15. So we're going to have 15, 15, 15, 15, 15, 15, and then the 200 will be
18.
Are you
It's
sure?
12. 12.
Check again.
12. 12 is correct.
Yeah, 12. Confirm.
Are you sure?
Yes.
Let's sum them up and see if you get the total 100.
It's 102.
So it's not so something is wrong somewhere. Let's cross check again. The total is 1700 or
Yes, please.
so 250 over 1700 times 100. What do we get?
14.7, therefore 15.
14.7. Oh, okay. So that is what is causing it. The decimals. And then the 200 will be 12. So here, let's assume that the 200 is, you say? Let's assume the 200 is giving us the 10. So that when we sum it up, it will be 100. Now the next step says that we should calculate the cumulative percentage of population. Do you remember that? We have to calculate the cumulative percentage of population. Then we calculate the same. So in terms of the cumulative percentage of the population, we only add in the percentages. So we have 27 for the first one. The next one is going to be 27 plus the 22, which you are going to get 49. And we do 49 plus 18. And that is going to give us, what are we getting for this?
67.
67. And we move to 67 plus 13 is giving us 80 plus 9 will give us
89.
Plus 7,
96.
96. And then plus 4 will give us 100. And we do the same for the before work and then the after the work. So we're going to have 7 plus 10, giving us 17. We will have 29. We will go for 43 plus 17 will give us 50. Then plus 19, we get 60.
This is 60.
So this one will be 60.
Yes, please.
Plus 19 will be 79. Then plus 21 will be 100. Then we do same for this one. We will have the 15, 30, 45, 60, 75, 90, and then this one will come in. Give us 100. Now, after doing these ones, after going through all these things, then we go back to draw our X and Y axis. So we go back to draw our X and Y axis. So I want to illustrate it here for you. Yes, so we just draw our X and Y axis here. And then the X axis is going to be the percentage of population or the cumulative percentage of population. And here is going to be the cumulative percentage of wealth. Now, you just draw the scale. In this case, you have 0 ranging from 0, the origin, to 100. So you can decide to number it from 10, 20, 30, 40 to 100. or you can go by 20, 40, 60, 80. That is the scale that you want to use. Then you begin the plotting. The plotting is going to follow something like this. Now, remember that if there is our scale, let's try and plot our question here. If there is our scale, then it means that first one, we're going to have to plot 27 as against, so we're going to plot the coordinates before and then the after. So if you look at this graph very well, you realize that it is true. The blue one is the before and the yellow one here is the after. So after you just draw the line of equity, that is the last step. You just move from the origin and connect to the 100. This is normally used when your arrangement is from the ascending order, from the least to the highest. But the one we are solving is from the ascending order. So we realize that when you plot, the curves are going to be like this. The next one will follow like this. So whether the curve is showing downwards or upwards, it's having the same effect. And the effect is that we always look at how close the curves are getting to the line of equity. If the curves are drawing near the line of equity, in fact, the line of equity means that there is a fair distribution of the income. So if you have a curve that is moving far away from the line of equity, then it means that there is a problem. So that is how you go through the steps. I will urge you to complete the one we are solving with your graph sheets so that you will see how the dynamics are. And then you come and complete based on the same conclusion as we have here. So the conclusion here for the first question is the same and it's applicable to the conclusion we have. The only thing is that this one, the curves are above the line of equity, and the one we are solving, the curves are going to be below the line of equity. However, we just want to know how close these curves are. So if the before is far away from the after, then it means that the introduction of the tax is effective. Now let me make it more practical. If you look at the table there, it means that naturally you realize that a lot of people within the organization are receiving very low salaries. If you look at this one, majority of the population are receiving 300 cedis per month. Let's assume that way. And then few people are receiving higher salaries. And that is how normally the organizational structure is. As you climb up the organizational structure, you have few people working within there. And these few people usually receive the highest share of the salary that is being paid. If you want to streamline issues or activities very well, then things being equal, we should tax those who are receiving higher income as compared to those who are receiving lower income. So if you check it very well, now 900, the person receiving 900, after the e-levy is now receiving 200. The person receiving 800 after the e-levy is now receiving 250, which is trying to communicate that at least there is a fair distribution of income within that particular populations. So that is one application of the Lawrence curve. So as we've gone through this illustration, please complete it, and maybe we may meet this one somewhere. Now, Jenny, so please try as much as possible to complete the question. I didn't ask us to solve this first one because already this one gave us the percentage population, the percentage income, which is the third and the fourth steps already the first two steps are done in this particular example. That is why I asked us to skip. When you want to go through the full steps, then the example that you made gives us the clear picture of the various steps that you're going to do. Any questions? Any question?
Yes, please.
Yes,
Doc.
so let me hear you.
Yes, please. Please, I can see from this illustration that the percentage population is in descending order. However, the income is in ascending order.
So the first step is always focusing on the percentage population. It says that we should always convert the population into percentages and rank them. And so the ranking is always with the population, not the income. And that is why the income, as you are seeing, the only focus is that is the percentage population arranged in a particular order. If the answer is yes, then we are good to go. We don't even care about how the income populations are showing. That is not our focus. Exactly.
Yes, please. Thanks.
I saw another hand up. Yes, Prince.
Please, Doc, my question has to do with the rounding of the after converting the population or the income into percentage. Assuming you get a decimal number, how are you going to round it up? Because from our question,
Yes, so
after
Prince, unmute and talk. You've muted yourself again.
okay, I was saying that after converting the population and the income, assuming you get from the question we solved, after running the numbers, the total was above 100. We had 102. So in that situation, what will you do?
Yeah, so technically, we're supposed to do is such that it add up to 100. And so if you are running, you have to be checking all these things. I resorted to the running because I wanted us to have an effective scale when it comes to the plotting. However, in the circumstance that we face, you realize that running will not be appropriate. So sometimes you have to leave them into their decimals. One decimal place or two will be appropriate. And then we go by that approach so that we have an effective solution. Is that okay?
Yes, please. Thank you very much.
So, any other concern? Yes, so if there is no concern, let's break for 5 minutes and then we start the second topic where we're going to look at presenting data using the descriptive statistics. So this is presenting data using the graphical methods. And we want to look at how we can present data using the descriptive statistics, the measures of central tendency, and the measures of dispersion. So the time is 1:13. Let's break for 5 minutes, and then we do some stretching and save some water, and then we continue. Hello. Hello.
Hello, Doc.
So we're now moving to look at the measures of central tendency, and it is the extension of what we did earlier on. Now we can present data, particularly looking at the center of that particular data. So here we mainly going to discuss the mean, the median, and the mode. Then we conclude it with the measures of dispersion, where our focus is going to be on the standard deviation and the various dispersions. So by way of revision, remember we discussed the various data sets, and we said that we have 4 levels of data measurement. Let's do a little extension to that one and say that normally when we have qualitative data, where we can classify them under nominal and then the ordinal, these 2 data will come together to form what we call the categorical data. Remember their explanation. They are the data sets that we can only put them into categories. So mostly qualitative data is also referred to as categorical data. So when you have a nominal data set like gender, male and female, they are in categories, so we can refer to them as categorical data. Again, when we have other data sets like our skin color or the color of our eyes, we can also have those respective categories, and so they are all categorical data. Now, ordinal data such as the student level, level 100, level 200, 300, and the rest can also be classified as categorical because they are only categorized into the respective level that these students have. Then the other side, where we have the interval and then the ratio, we can now also consider these data sets as a continuous data. And so the continuous data is normally quantitative or numerical. So the 2 types of the quantitative data, as we discussed earlier, falls under the continuous data. So we have to take note of this development. Now we add into the type of data, and we can now have another category saying the categorical data and the continuous data. Now, from there, we can have this summary, which represents the entirety of all that we're going to do here in this particular topic. So usually, we go back to the type of data measurement to form the basis of the appropriate measure of central tendency, as well as the appropriate measure of dispersion. And recall that measures of central tendency, we only want to locate the center of a data. So this is just looking at the average of the data. And then this is also looking at the dispersion, how each other observation is moving away from the average of that particular data. And so for nominal data, normally we use a mode to represent the average, and the appropriate dispersion will be the percentiles. And then for ordinal data, the median is appropriate. Then we use the quantile deviations to also serve as their dispersion. Then for interval and ratio, we use the mean to represent. In other words, I can say that the continuous data, we can use the mean to represent the measure of central tendency, while the standard deviation represents the most appropriate measure of dispersion. So this table is very important, and we should have it in mind as we move through. So let's look at the measure of central tendency. It is just looking at the center, or it is just looking at the central location of the data distribution. For example, when we have a given set of data, how do we know the average of that particular data set? We use the central tendency to strive the average of that data set. So it has so many names: the measure of central tendency, the measure of location, the average of the data. All these are just still representing how we can locate the center of a data. And we have three major types of central tendency. We have the mean, the median, and the mode. The mean, we know that we get the mean by adding all the observation and dividing it by the number of observation. That is why it is most appropriate when we are using quantitative. If you are using qualitative like West, there is no way you can add. So how do you add male to female and divide it by the number of observation? That will not happen. So normally it is appropriate when you are talking about numbers, and that is why we use the mean for those continuous data. And then the median is looking at the middle number, and the middle number is always given when we are able to arrange the data from least to highest or highest to least, and then we are able to spot the middle position after arranging, and then by so doing, we are able to locate the middle or the center of that particular data. So median is just the middle value. Then the mode is also looking at the most occurring value. For instance, if you have a given data distribution, you just want to know which one is occurring most, and then that's one which is occurring most becomes or represent the average of that particular data set. And it's also based on the fact that if data is measured using nominal, because they are weights and kept into categories, you cannot really know the natural flow of order among those data sets. For example, if you have the eye color, those with the brown, others have a blue, some are black, and the rest. You cannot really determine which one is higher than the other, but you want to understand from the given number of people that you want to study, how many of them have blue eye, how many have the black. So by basing on the number of people having A or B, you can now rely on the highest occurring to represent the average or the middle of that particular data distribution. So these are the three that we are going to focus. However, our focus is going to be on whether the data is grouped or ungrouped. So by grouped data, the various examples that we saw in the graphs, where we were categorizing the data from 0 to 5, 6 to 10, and the rest are grouped data. And we go through the various approaches to group them. That is not the focus of the class anyway. Our focus is going to be on if the data is already grouped, how are we going to compute the various measures of central tendency? And we are also going to do so for a sample and a population. By sample, we are looking at that part of the total element that we want to study. And then the population is looking at the totality of the element within the particular area of study. So that is how we're going to go about it. So by symbol, when we write this X bar, we are looking at, for example, the mean of a sample. And when we write this symbol, like the U, that we call the mean, then we are looking at the mean of the population. So you should be watching at how the formulas are going to also change. Now let's focus on the mean. The mean, we have three types of the mean that we will focus on. The first is the arithmetic mean, which is the simplest or the normal mean that we know. Then we will talk about the geometric mean as well as the harmonic mean, and when or how we use each of these particular types of mean. With the arithmetic mean, we only going for the normal definition of the mean, where we're looking at adding all the values and dividing it by the number of observations. And so the formula for an ungrouped data is simply you adding the various values. So you have the summation of all the values. So let's assume the values are the I values, and then you divide it by the N, which is representing the number of observation. So for example, when you have this given set of values, let's say we want to know the age of 6 students in the class, and then they are able to tell us that their ages are 21, 28, 36, 40, and 27. Out of this age, they are not good. They are individual values, and so we can apply this formula, and then we get the mean to be equal to 21 plus 28 plus 36 plus 40 plus 27, everything divided by the number of observation, which is 1, 2, 3, 4, 5, 6. So when you divide it, is it 5 or 6? 1, 2, 3, 4, 5. So 5. When you divide it by 5, that gives you the mean age. So somebody should point it for me and see what will be the mean age of this distribution.
30.
The answer is 30.
Yes, please.
Okay. So this is how we compute the arithmetic mean, particularly for ungrouped data. Now let's look at the arithmetic mean for grouped data. Arithmetic mean for grouped data. In that case, our mean is now going to be the summation of fx divided by the summation of f. Because they are normally grouped, they come with frequency. So anytime you see a data or a given set of questions with frequency, it means that they have been grouped. And the frequency is telling you the individual values that constitute a particular class. So once there is frequency, then the formula changes from the summation of the individual items to the summation of when we multiply the frequency by the individual items. Then you divide it by the total frequency, which by nature is the same as the n, because the n is representing the number of observations. So it is the number of observations that have been kept in the frequency. So when you sum all the frequencies, it do give you that particular values. Let's try this example and see how best we can get. So let's assume these are our class, and we have 2, let's say 1 to 5, we have 6 to 10, we have 11 to 15, then we have 16 to 20. Then the frequency, we have 10, 8, 6, and 12. If you want to apply this formula, then it means that you have to get the class midpoint. And that class midpoint is what is going to represent the x in the formula. I hope you are following.
Yes,
Yes, sir.
Yes. So you compute the class
Sir,
midpoint.
sir, please come again, I beg.
Yes. So we are trying to compute the mean for this question. So we have the class where we have 1 to 5 with a frequency of 10. We also have 6 to 10 with a frequency of 8. We have 15 to 20 with a frequency of 6. And then 16, we have 11 to 15 with a frequency of 6. And then 16 to 20 with a frequency of 12. Because we want to use this formula, once it comes with frequency, because we cannot use the first one, we have to rely on this formula. And by doing so, you have to construct this table. So the table will simplify your solution, and the table will come with the class, the frequency, and then you have to compute the class midpoint, just like we saw under the graphical approach. So the class midpoint becomes the X value here in the formula. So the midpoint that you are computing becomes the X value. And then you have X multiplying your frequency. So we have to compute the midpoint. So 1 plus 6, 1 plus 5 divided by 2 is going to give us 3. And then 6 plus 10 divided by 2 is going to be 8. 11 plus 15 divided by 2. What value do we get? 13. And then 16 plus 20 divided by 2 will give us 18. So calculating the class midpoint gives us the X values we have in the formula. And then once we get the X values, we have to go ahead and compute our frequency times the midpoint. And that is the Fx that we have here. The frequency is multiplying the midpoint. We're going to do 10 times the 3 to give us 30. 8 times 8 to give us 64. 6 times 13. What do we get?
78.
And then we do 12 times 18.
216.
216. Now the formula says that we should find the summation of our frequency multiplying the X. So we add the 30 to the 64 to the 78 to the 116. What do we get?
388.
388.
88.
Then we also find the summation of our frequency, where we add the 10 to the 8 to the 6 to the 12.
36.
36. So for us to get our mean, we are now going to do 388 divided by 36, and that gives us the mean. What's the final answer?
11.
11. So 11 becomes the mean of this particular data. Any question?
Please, Doc.
Yes, sir.
Please, actually, 10.777. So, can you maintain a decimal or 2 decimal places and make it maybe 10.78?
Yeah, the 2 decimal place is appropriate.
All right, thanks.
Yes, so this is how we compute the arithmetic mean for both grouped and ungrouped data. Now let's move to this example. So for this example, you want to understand or know the average of this illustration. So when you have 7 directors in a particular company, that are saying that out of the profits we had, we should retain certain amount. There are various suggestions of amounts that should be retained, can be added together, and that is a solution here. So this is just an arithmetic mean for ungrouped data. Arithmetic mean for an ungrouped data. And when you add the 10,000, 12,000, 15,000 to the 20,000 and divide it by the 7, then you are able to get the average amount that they want to. You're able to get the average amount they want to retain. So this is similar to the ungrouped arithmetic mean that we discussed. Now, there are other situations where we want to get the weighted mean. We want to get the weighted mean. From that illustration, you realize that the weighted mean is simply saying that we cannot mainly rely on the arithmetic mean sometimes, especially when the contribution of these individuals are not the same. So we apply the weighted mean approach, which is going to help us to truly identify the weight of each contribution as against how we are going to make decisions. A typical example is when we come to, let's say, partnership. Let's assume that we are individuals coming together to do a business together. And then we decide to contribute certain amounts. So let's assume 3 friends came together, and then their contribution, A is contributing, let's say, 500 cedis. B is contributing 1,000, and then C is contributing, let's say, 1,500 into the business. Now, when it comes to taking decisions for this particular business, we want to understand the weight in terms of the contributions that individuals made. So all things being equal, we can report that the amount of money you pay into the business probably will give you that right. Will give you that right in terms of making decisions. So let's assume that out of our operations, we made profits and we want to share this profit. If A says that we should share or we should retain, let's say, 1,000 of the profits, and B is also saying that we should share, let's say, 800 of the profits, and C is saying we should share 700, you could see that when we want to make a decision, unlike the previous one that we added the amount that they suggested and divided it by the number of individuals, here it will not be fair for us to do that same computation, because if you look at the amount of contribution by each of these individuals, clearly it tells you that they shouldn't have equal say when it comes to taking decisions for the business. And so we can now resort that we should take our decision based on the amount that you contributed. And that is what the concept of the weighted mean is trying to preach. The weights per every individual should be considered in terms of making a decision. And if you are going by that approach, then our weighted mean, which is represented by the X bar of W, is simply giving us the summation of the weight of each individual times its amount divided by the summation of all the weights. So if you want to solve this question, then the summation of the weights is going to be 500 plus 1,000 plus 1,500, which is 3,000. And so for us to get the weight per each person, we can have 500 over the 3,000 in that particular order. Or we can also decide to multiply the weight by the profit, which is the amount per each person. So we do that, and then we also get the summation of the X multiplying the W and divide it by the 3,000, which is the summation of the W. So we can do 500 times 1,000, which will give us 500,000. That is following the same approach that we did here, like the summation of the fx, where we were now multiplying the frequency by the x. We can do the same thing here, and in this case, the profit becomes our x. And so we multiply the w by x, which is 500 times 1,000. We get our 500,000. We multiply our 1,000 by 800. We get our 800,000. Then we multiply our 1,500 by 700. And what do we get? $105.
1050. 3 zeros.
3 zeros. And then we find the summation. We get a summation of XIWI. What's your summation?
2350 3 zeros.
2350.
3
We're going to
zeros.
do 2350 divided by 3,000.
$783.33.
783.3. Okay. So this is how we get the weighted mean. So this is another approach, and the weighted mean is an extension of the arithmetic mean, where it is trying to explain that sometimes we cannot compute the arithmetic mean, especially when the contributions or the shareholdings or the amount they are investing are not the same. In that case, we will consider the proportions of their investment, and then we multiply it by the respective amounts. And so this formula becomes similar to that the good data, where we have the summation of fs. So the f is replaced by the w, and that is how we go about the weighted mean. Now let's move away from this to the let's try this particular question. Right, I'm giving you 5 minutes to try this one, and then we go ahead.
The income of workers employed by A&E.
So please solve, and then we compare
The
answers.
number of workers are indicated as the chief accountant. The weighted average income compute for the The income of the employed by him was ordered 170, 260, 350, 590.
Rita, you have unmuted yourself.
Hello.
Hi, sir.
I told you to solve it and give me the solution.
So we are on it.
So 5 minutes. That is why I muted myself.
Okay.
Yeah, so how is it going? Do you have an answer?
Yes, Doc.
Yes.
So what's the answer?
I had 1,354.53 Ghana cedis.
Repeat your answer for me.
1,354.53 pesos.
Any other value? Hello.
So I had 1,354.53 pesos.
1354.53.
Yes, sir.
Yes. I saw a hand up. Are we all getting the same figures?
Yes,
Yes,
please.
please.
That is it.
Okay. So you have to always pay attention to whenever you're giving the question. You have to pay attention which of the values is constituting the weight and which ones are constituting the actual X values. So in this case, the income of workers employed by AMA was recorded as. So it should tell you that you are now interested in the incomes. And so the income values become the X values. And then the number of workers becomes the respective weight. All right, so let's move on to the geometric mean. Now, the geometric mean here is usually used to compute the mean, especially when we're talking about percentages and rates. So whenever the question is giving you percentages as well as rates, you just ignore this formula. We are going to compute the geometric mean using this particular formula, which is saying that we should find the nth root of when we add 1 to the respective percentages or rates, and then we multiply these products, and then we do -1. So we're going to have the nth root of 1 plus x1 multiplying 1 plus x2 plus multiplying up to xn, the last value, 1 plus the last value. So let me indicate it for you. We're going to have the nth root of, so you're going to have up to the last 1 plus xn, everything -1. So if you have 1 plus here, 1 plus the x1, everything. Or when you want to use the anti-log approach, you can use this. I'll prefer that you stick to this particular formula. So we're going to have the nth root of when we add 1 to the respective. Now, the n there is talking about number of observations. And so, for instance, if we have to compute the rate for, let's say, we want to compute the mean for the following rates. Let's assume you have, let's assume you have 10%, 15%, 20%, and then 25%. Let's try this question and see. In this case, our geometric mean is now going to be equal to, because you have 1, 2, 3, 4 observations, you're going to find the fourth root of 1 plus 10%, which is 0.1, multiplying 1 plus 0.15, multiplying 1 plus 0.2, also multiplying 1 plus 0.25. So everything minus 1. That gives us our solution. I hope it's clear.
Sir, please come again.
Hello, are you with me? Yes, so when you are given these values and you want to compute them, you just substitute them because the observations are 4. Your n in this formula becomes 4. And then all that you have to do is to bring the first rate plus 1, multiplying the next rate plus 1. In that order till you get to the last rate. And this whole thing will be computed, and the final answer, you take 1 from it. So you're going to have the fourth root of 1 plus 0.1. The 0.1 is representing the 10%. The 0.15 is the 15%. 0.2 is 20%. And 0.25 is the 25%. When you're able to resolve all this, and then you take 1 from the answer, and that becomes your final answer. Is that okay?
Yes, sir.
Right. This is Let's try this example. Let's try this example. So we have Christy earning 6,000 a year, and the income is growing by 10%, 15%, and 13% respectively. And we are to compute the average growth rate. So the first part of the question says we should compute the average growth rate. So the average growth rate is where we're using the geometric mean. And here we said that the formula n fruits 1 plus the first rate multiplying 1 plus the second rate. Because the rates are 3, you do 1 plus the third rate, everything minus 1. And so we have 13, we have 10, so we have 3, the cubic root of 1 plus 0.1, multiplying 1 plus 0.15, multiplying 1 plus 0.13, everything minus 1. So what will be the answer? Goes with the calculator.
Please, the answer is 0.75.
0.75. Any other? So here, how you point the calculator is very key. Any other? Let's try it again and see. So first you do the ones in the brackets. So let's simplify it further. We're going to have the cubic root of 1.1 multiplying 1.15 multiplying 1.13, everything minus 1. So let's multiply the ones in the brackets first. 1.1 times 1.15 times 1.13. What do we get?
I got 1.42945.
So we get a cubic root of 1.42945 minus 1. So find the cubic root of your answer. Are you using a calculator? Or are you using your phone?
We are using the calculator.
So you should find the cubic root on the calculator.
So I had 1.965.
The cubic root.
Okay. 1.96597.
Any other answer?
Please,
Did you
I
try
also had 3.59.
I critical.
Please, Doc.
What did you get?
The cubic root, I had 1.126478714.
That's the figure I'm looking for. 1.126. Repeat your figure for me, Mark.
1.264
Mine is
78714.
Daniel.
1.1264.
1264.
Yes.
Okay.
78.
Okay. So let's say 1.1265.
All right.
Okay. Mark, did you have a different figure?
not 1.965.
So the problem now is how we point, how we
I
use
use
the
the phone.
calculator.
I use the phone. I didn't use the calculator.
Calculator. So we should get what Daniel gave us, 1.1265. And then when we do the -1, the final answer is going to be 0.1265, which is the same as 12.65%. %. So please, let's take our time and then punch it well on the calculator. Ideally, you can even enter the whole thing once on the calculator, and it should give you something close to the 0.1265 as an answer. So please, let's revise. I know we can use the calculator. Let's revise the use of the calculator so that in exams, you may have all the steps, you may have all the ideas. Your final answers will not be different from what is expected of you. So this is how we compute the geometric mean. So we now have computed the average growth rates of this particular question. Now, the second part of the question says that we should find the total amount by which the income will grow. So for you to get the total amount, we go by this formula. Total amount is giving us the amount multiplying 1 plus r raised to the power n. 1 plus r raised to the power n. So by this new formula, our amount is the one given in the question. Our amount is the one given in the question. So if you look at the question very well, we have 6,000 representing the amount. So we have 6,000, and then the 1 plus the r. The r is the one we have computed, which is the 0.1265. Then we raise it to the power n. N is the number of years. Remember, the income is now growing year 1, 10%, year 2, 15, and then year 3, 13. So n is equal to 3. Then we are able to also get the amount. So we go by that formula, and we are able to compute as such. I hope it's clear. Let me make it clear here. After computing the after computing the R to be getting the R to be equal to 0.1265, then we go to calculate the total amount at the end of the 3 years as the amount invested or the amount you have from the scratch multiplying 1 plus the R that you've computed raised to the power n. The n is the number of years, and by the question it is 3 years. So we're going to have the 6,000 multiplying 1 plus 0.1265 raised to the power 3. So let's solve this one also. Hello, are we working?
Yes, please. Yes, dog. The one plus 0.1265 to the power 3, I had 1.4295. So when I multiply by the 6,000, I had 8,577 Ghana cedis.
8577.
7. Yes, please.
Okay. Prince, you getting the same answer?
Yes, please, Doc.
That's it.
All right. So this is how we go about this question. So usually you have to pay attention to the values in the question. If the question is giving you percentages, then it means that you should go by the geometric mean approach. Now let's move on to the other one, which is the harmonic mean. Now the harmonic mean usually is used to compute the mean for ratios. Here we are now interested in something that is in the form of proportion. And so whenever you have proportions like this, then you can now rely on the harmonic mean. And now rely on the harmonic mean. And so, for example, when you have values that is given in this proportion form, like the mile per kilogram, kilometer per hour, and the rest, then your formula is changing. Now, the formula is now changing to this, where you are going to find the reciprocal of the arithmetic mean. You only turning the arithmetic mean down, upside down. And so the formula, instead of resumming the x values and divide it by n, we are now going to bring the n on top. And then we're going to have n over the x values to find the reciprocal. So we do 1 over each x value plus 1 over the x2 in that particular order. And so it is just this formula we have here, the summation of x over n, that we are trying to find the reciprocal of each value, and then we use it to resolve. And this is only applicable when the unit of analysis is in the form of a ratio. For example, the following data relates to the fuel consumption achieved by 5 managers in a company. Now we have manager A, B, C, D, and E, and their consumption in the unit mile per gallon. And so the mile per gallon is telling you the ratio. And once you see such values, it means that we cannot use the arithmetic mean, but rather we go and then we use the harmonic mean, which says that we should find the reciprocal of all the values as well as the formula. And so in this case, when you are solving this one, it means that our harmonic mean is going to be computed as, we're going to have n, which is 1, 2, 3, 4, 5. We're going to have 5 divided by, then we do 1 over 23 plus 1 over 25 plus 1 over 26 plus 1 over 29 and 1 over 23. So the 5 will divide everything when we find the reciprocal as such. I hope it's clear.
Yes, sir.
What will be the final answer when you go by this approach?
Doc, please, I had 25.01.
25.01. Julie, do you have a different answer?
So I'm getting confused.
Don't use that word again. What's the issue? Where is the challenge?
So in this case, with this, we have to find the LCM, the common multiple
Just use your calculator.
calculator.
Mm. So when you have the calculator, just enter 1 over 23 plus 1 over 25 plus 1 over 26 plus 1 over 29 plus 1 over 23. It will simplify it for you. And then the answer you get, you do 5 divided by the answer.
Okay.
Mhm. Teachers and their approach. They are not learning the concept of fraction. So any other issue before we move on?
Okay, so I also had it. I had 25.01.
Okay, that's fine. So let's move on. So yes, this is the solution. Let's try this one. These are the example. In a certain factory, a unit of work is completed by A in 4 minutes, by B in 5 minutes, by C in 6 minutes, and by D in 10 minutes, as well as E in 12 minutes. What is the average rate of working? So remember we said that the harmonic mean is applicable when we have the ratio unit. So this one, the answer was given in the unit mile per gallon. If you look at this particular question, you realize that you are looking at the rate of day finishing a work in minutes. So it is going to be 1 unit of work done per minute. 1 unit of work done per minute. And that is why it is harmonic. So let's go through the same formula and then simplify this one. When we're done there, we move on to the other forms of central tendency. So let's work faster. We are doing well, but the rate of finishing a question is still slow. So let's try hard and then finish as quickly as possible. This one should take us like 2 minutes. How is it going?
Please, I had
What do you get?
6 point.
6 points. Hello.
Please, Doc. I have
So
6.25.
Please, I have
2.5. Are you all getting that value?
6.25.
I want to hear my ladies. Okay.
Yes, please. 6.25.
Julie, are you also there?
Yes, sir.
Okay, so we can close chapter on the mean and then move to the median. Now, as I explained earlier, the median, we are looking at the middle value. We are looking at the middle value. However, before we get the middle value, we need to estimate the median position, especially when we are talking about ungrouped data. So for ungrouped data, we have to get the median position first. And then when we have the median position, we can now get the middle value. So the step says that we should just rearrange the values in ascending order or descending order. And then we get the median position using this formula, n plus 1 divided by 2, where n is looking at the number of observations. Then we are able to spot the position. That is not the median, but that is a median position. In other words, that position is where we can get our median. So we do these steps. So, for example, find the median of the following set of data. All that we have to do is to rearrange these values in ascending or descending order. So which approach do we go? Ascending or descending?
Ascending.
Let's go ascending.
Ascending. So which one comes first?
1.
Mm-hmm.
2.
Okay.
We are 2 5s.
You have 1, 2, 1, 2.
5. They are 2.
5, 5.
Yes, please. Then 7.
4 is in there.
So there was 4.
sorry.
You
You
didn't
left
see
out
the
4.
So, so let's bring our 4 here. We have 1, 2, 4. Then we have 5, 5. Followed by
7.
7.
We have 9,
9 will come in.
10,
10
13.
and 100. Okay. So after doing this, then we calculate our median position, which is saying n plus 1 over 2. So what is our n? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 plus 1 over 2, which gives us 5.5. So 5.5 here simply means that our median is going to lie between the 5th and the 6th observation. Are you following? The 5.5 means that the median is going to be in between the 5th and the 6th observation. So we just count 1, 2, 3, 4, 5. And so between this 5 and the 6 is our median. So normally we see that if we compute the median for an even distribution, then it means that we're just going to add the middle values and then divide it by 2. So once it is 5.5, it means that after the 5th observation, we are going to see the median. So we add the 5 to the 7 and divide it by 2. And this is done because it is not falling on any particular value. When you do this, you get 6 as our median. Because 5 plus 7 is 12, divided by 2 gives us 6. So our median is 6, and the median position is 5.5. That's the 5.5 position. So that is how it is. You can also have this illustration. Let's assume that the 100 is not part. So when we are rearranging, this is not part. So let's assume this is off. And then we are left with 9 observations. So we're going to have 9 plus 1 divided by 2. Here, our median is going to be on the 5th position. And so the 5th position, we just count 1, 2, 3, 4, and it is going to fall on the 5. So 5 becomes our median. And so that is how we should balance the median. This is for ungrouped data, and it is very simple. When you are looking at the ungrouped data, it is very simple from this angle. Now let's look at the grouped data. Now when you have the group data, the median is now computed using this formula. So our median is going to be equal to our L plus N over 2 minus M, everything divided by F, multiplying the C. So the whole of this is supposed to be done first, then you add it to the L. But you should know what each of the variables is representing. And so, for instance, the M in here is representing the median. Our L is looking at the lower limits of the class boundary. Our L is looking at the lower limits of the class boundary. And then the M here is looking at the cumulative frequency above the median class. So take note of the meaning of the variables. When we are solving the example, we will come back to explain it further. So the M is looking at the cumulative frequency above the median class. Don't forget that we did cumulative frequency when we were looking at the graphical presentation. And then the F here is looking at the frequency of the median class. For the ungrouped data, we did the median position. Now, because it is grouped, we are now going to have the median class, which is the same as the median position. It is that class that we are likely to have our median. That is the median class. The N is the same as the summation of F. When we sum the various frequencies, it gives us the N. And you should recall that earlier on I said that when you have the mean to be equal to summation of X over N, the N is the same as we looking at summation of Fx over summation of F. The summation of F here is the same as the N. So the N is the summation of the frequency. And then our C here is just representing the class width, the difference between the lower boundary and the upper boundary. That gives us the class width. So let's stick to this formula. When we get to the illustration, we will come back to look at how we can expand or simplify this particular formula. I hope you've captured it. Hello. Hello.
What's up?
Yes, so can we
Hello.
can I move on?
Yes, sir.
Yes, please.
Okay. So let's continue with the mode and then we solve a question together. The mode I explained that it is just looking at the most occurring value. And so you just have to study, for example, if you have the on-group data, you just have to study the observations and look at the one which is most occurring, and that represents the mode. For example, with this one, you realize that the 3 is representing itself 5 times. And so it becomes the most occurring value, and that becomes the mode. And whenever you're given a given data set, you just have to cross-check and know which of them is the most occurring. And that is the mode, especially when we're talking about ungrouped data. Now, when we have a group data, similar to the median, we're going to rely on this formula. And so for group data, let's capture the formula. The mode is going to be equal to A plus, bracket open, D1, dividing D1 plus D2, and everything multiplying the same class with. Yes, so with this particular formula too, the A here is similar to the L we saw in the median formula, which is looking at the lower class boundary of the model class. And then the D1 is the difference between the frequency of the model class and the frequency just before the model class. D2 is the frequency, the difference between the frequency of the model class and the frequency just after the model class. So it is similar in terms of the values that you're going to see and the techniques that you're going to use to resolve. So let's just capture the formula again. Then we go through an illustration. However, remember that the model class is just representing the class with the highest frequency. So you just look through the question. The class which is having the highest frequency becomes the modal class. So from here, let me quickly add that for on-group data, you realize that you can sometimes also have more than one mode, which simply means that 2 or 3 values may be occurring at the same number of times, and that represents the mode. So let's take note of these developments. So let's quickly look at an example if you've captured the formula. Can we move on? Hey, are you there? Hello?
Yes, sir, we are here.
No, you are not talking. It seems you are tired.
No, please. We want to note down there.
Yes, so let me know when you are done writing the formula.
All right, Doc.
Yes. Hello.
Yes, so can we move on?
So please, I lost connection, so I just reconnected my network.
Sorry about that. Can we move on to look at the example?
Okay.
Yes, please.
All right, so let's calculate the median and the mode from the table below. So remember the formulas. Let's rewrite the formulas here, which should guide us in what we are supposed to do in terms of table. So for the median, we said that we're going to compute using the L plus, we open brackets, we will have n over 2 minus our m divided by our frequency multiplying our c. And then for the mode, we said that we're going to have a plus bracket open d1 over d1 plus d2 multiplying our c. So by explanation, it simply means that we need to get our cumulative frequency because that is what the D is looking for. And then our D1 and D2 is also relying on the cumulative frequency. Remember, the M is just looking at the cumulative frequency as we indicated here. M is the cumulative frequency above the median class. So it means that we have to get the cumulative frequency. And then once we get the cumulative frequency, D1 is looking at the difference between the frequency of the modal class and the frequency just before the modal class. And so we only need our cumulative frequency. And how do we compute for the cumulative frequency? We only getting the cumulative frequency by adding our frequencies. So we're going to have 2, and then we add 6 to the 2 to get 8. Add 8 to the 8 to get 16. We do add 12 to the 16 to get 28. Plus 10, 38. Plus 4 becomes 42. And finally, we get 44. So that is our cumulative frequency. So the question is, we need to get the lower class boundary. Remember, the L is representing the lower class boundary. And so we need to get a lower class boundary. Now, we can even use this same example to compute the mean, but that is not the focus. And so when we are to compute the mean, it means that we have to get the midpoint and the rest in addition. Now, because we only need the median and the mode, we're only going to compute the cumulative frequency as we have done, and then we can pick the other items. Or we can also decide to convert this one into the class boundary, where we are now going to do minus 0.5 to the lower and plus. Already it is in the boundaries, right? The question is in the boundaries. Because you have 0 to 5, 5 to 10, 10 to 15 in that particular order. So we can straight away go and compute our median. In this case, our median is equal to the lower class boundary of the median class. Now, how do we get a median class? We only have to count 1, 2, 3, 4, 5, 6, 7. The median class is the middle one, just like how we got the median position. So we're going to have the middle one. So we do 7 plus 1 divided by 2, which is the fourth position. So 1, 2, 3, 4. This becomes the median class. So we just use the median position approach and we get the median class. Once we get the median class, L is the lower limit of the median class. So our L from this question is 15. the lower limit of the median class, 15. Then we go to compute for our n. N is simply the summation of the frequency. So the summation of the frequency is 44. So our n is also equal to 44. Then we go for m. We said that m is representing, let's go back. We said m is representing the cumulative frequency above the median class. So when we check the cumulative frequency, the one above the median class is 16. And so the median class is the one with the 28. So the cumulative frequency above the median class becomes the 16, which means our m is 16. And then we go to f, which is also looking at the frequency of the median class, which is 12. The C is representing the class width, which is the difference between the upper class boundary and the lower class boundary. So 5, or we can do 20 minus 15, which is 5. So our C is also equal to 5. Then we substitute into the formula. We substitute these values into the formula. Doing so, we are going to get our median to be equal to 15 plus, then we open brackets, our n is 44 over 2 minus our m, which is 16, everything divided by f, which is 12, multiplying the class width of 5. Then we simplify. Are you following? Are you with me?
Yes, sir.
Juliana, is your network okay now?
Yes, sir.
Yes, so this is how we compute the median for good data. You first have to be able to spot the median class. And we follow the same approach as we did for the on-grouped. Once we get that one, then we are able to get the element in the formula. L, we said, is the lower class of, is the lower class boundary of the median class. And then our N is the summation of the frequencies. M, we said that it is the cumulative frequency just above the median class. And then our F is the frequency of the median class. And then our C is the class width. Once you're able to do that, we simplify. So we're going to have 44 over 2, which will give us 22. So 22 minus 16 is going to give us 6. So we have 6 divided by 12, which is giving us 0.5. 0.5 times 5. That is going to give us around 2.5. Then 2.5 plus 15. So our median is going to be 17.5. Are we getting the same thing? Hello.
I said.
The energy is going down. If there is any confusion, let me know so that we go over it. Is there confusion?
Yes, I'm getting a little bit
Yes,
confused.
Please, dog.
Let me take Rita first.
Please.
Doc, please. How do we get the C? The 5.
The C is the class width. So the C When you take the median class, you do the upper, which is 20, minus the lower, which is 15. And that gives you the C.
Oh, okay.
Then I come to Julie. Julie, you were saying something. Augustine, I'll come to you. Yes, Augustina, you are saying something. Julie, your network, I'm not hearing you. Okay, let's hear you. Any other confusion? Let's clarify and then we move on.
Yes, please, Doc.
Daniel.
Yes, please. I know with the median for this kind of question we are using we are solving for group data.
Mm-hmm.
Please, that the n+1 divided by 2 where you had the proposition. I don't understand why it comes in here.
Yes, so usually we don't even rely on that, but for you to get a median class, which is the same as the median position, remember the ungrouped, we were interested in getting the median position. So here, our interest is not like the median position, but a median class because it is grouped. And it's rely on the same thing. So we want to identify which of the classes is in the middle. Already we've done the arrangement. So the classes are starting from the lower class to the higher class. So because we need to get that class which lies in the middle, that is why we went for the median position. And the other items that we are of interest rely on we getting the median class. So it is just helping us to get the median class, which by looking at it, you can easily locate the middle. Is that okay?
Yes, Doc, thanks.
Mm-hmm. Any other clarity? Any other? So once you're able to identify these issues, you just substitute them into the formula and you simplify. So just like how I did it, you do focus on the one in the brackets first, where you can simplify the fraction, and then you take your 16 out of it, you divide the answer by 12, you multiply it by the 5, you come and add it to the 15, and that is giving you a straight answer. So let's use the same approach to solve for the mode. Let's use the same approach to solve for the mode. So for the mode, we don't even need the cumulative frequency, because the formula says that we should calculate the modal class first. Once we get a modal class, you're able to locate A, which is the lower value of the modal class. And then we do D1. D1 is the difference between the frequency of the modal class and the frequency above the modal class. And similar to what we saw in the median, how we got the median class, we're going to follow the same thing. So the mode is equal to A plus D1 over D1 plus D2 multiplying the C. And D1 we said is the difference between the modal class. So let's locate the modal class. The same way we did for the on group data, we said the mode is the highest occurring number. So for the modal class, we are just interested in the frequency, the highest frequency. And from this question, the highest frequency is 12. So 12 gives us the modal class because it is the highest frequency. Modal class. Now, once we get a modal class, A is the lower value. Our A becomes the lower class boundary of the modal class. So A becomes 15. And then D1, we said, is the difference between the frequency of the modal class, which is 12, and the frequency above the modal class, which is 8, giving us 4. D2 is equal to the difference between the frequency of the modal class 12 minus the frequency next to the modal class, that is 10, giving us 2. I hope you are following how I got the D1 and D2.
Yes, sir.
Yes, so you only have to follow 2.
Sir,
Yes, ma.
hello, sir. Yeah, please, I beg you. My network went off. I just came. Please, can you just go back small?
So we're saying that for you to be able to solve the median and the mode, you always have to first locate the modal class and the median class. So for you to get the modal class, we are saying the modal class is the class with the highest frequency. The class with the highest frequency becomes the modal class. When you look at the question, the highest frequency is 12. And so that class becomes the modal class. Once we get that one to be the modal class, then we will trace our A, which is representing the lower class boundary of the modal class. So A is the lower class boundary of the modal class. In this case, A is 15. And then we also do the D1. D1, by definition, we say that it is representing the difference between the frequency of the modal class and the frequency above the modal class. So the modal class frequency is 12. The frequency above the modal class is 8. So you do 12 minus your 8, and it gives you 4. That is D1. Then also, D2 is the difference between the frequency of the modal class and the frequency below the modal class. So the frequency of the modal class again is 12. The frequency below the modal class is 10. So you do 12 minus 10, which gives you 2. Then once you have this, our C again is the difference between the upper boundary and the lower boundary of the modal class. So we still have 20 minus 15, which gives us 5. So once you have these values, your mode is now going to be equal to A, which is 15, plus the D1, which we have 4, over the D2, D1 plus D2. So you're going to have 4 plus 2 multiplying 5. And so when you simplify, you're going to have 4 divided by 6 times 5 plus 15. What do we get? 4 divided by 6 is 2 over 3. And that is like What answer do we get? Hello. What answer do we get?
18.33.
18.33. Are we getting the same thing? Any confirmation?
18.33.
Okay.
Yeah, confirmation.
All right. So this is how we go about computing the mean, the median, and the mode. So this same question, you can be asked to compute the mean, the median, and the mode. And by so doing, you have to complete this table. Remember, we needed the class width, and we have it here. And then if you are computing the median, you also need the cumulative frequency here. And then the mean will require that you calculate the class midpoints. So you do the midpoints, which will now force you to compute the frequency times the observation, fx. Then you do those ones also here. And that is how you compute your mean and the rest. So there are some of the sessions that probably may not be necessary, but this is how you go about computing the mean and the median. These ones will come in when you are computing other values. And so let's quickly move to the measures of dispersion. Then we are able to, so this is our median that we computed. We had it correct. Then our mode was also 18.33, which is also correct here. Now, some small reading assignment for you. You should go and compute or read on the advantages and disadvantages of each of these central tendencies. And also indicate which one is appropriate and why do you think it is appropriate. So let's write it down. Let's read. Let's read on the advantages and disadvantages of the mean, median, and the mode, and which of them is appropriate measure of central tendency. Hope you've captured it. Hello.
Hello. Yes, sir. We have.
All right.
Hello.
If you don't respond, I don't know whether you are hearing me or not.
Okay.
So let's now look at the measures of dispersion. And then we can close in the next 30 to 45 minutes. So measures of dispersion, we are now looking at how each observation moves away from the center, the observation. So remember the first example we looked at with respect to the mean. We said that if you want to know the average age of let's say 5 students. We just add the respective ages and then we divide it by 5. Now, if assuming the 5 ages, the average is, let's say, 30, doesn't mean that all the 5 are having the same age, 30 years. However, they have their respective ages, and these ages may be different from the average that we've computed. So the dispersion basically looks at how each of the other observations move away from the center. And that is what we mean by measure of dispersion. So it just refers to how the data is spread about the measure of central tendency. And it is a measure of variability. So one of the applications is that we are able to look at how variable, consistent these values are. And then we can also use it to assess the risk when it comes to investment, and then how reliable that results are also showing. So that central tendency that we've computed, how reliable is that value that we're using to represent, let's say, the median, the mode, or the mean. And this is the dispersion. So it ranges from recomputing the standard deviation, coefficient of variation, the variance itself. We have a whole lot of them, semi-interquartile range, and talk about the coefficient of skewness and the rest, a lot of them. But let's just focus on the computation around the standard deviation. And for us to compute the standard deviation, we first consider the mean deviation. We will come to the mean absolute deviation. And then we look at the mean squared deviation. The mean squared deviation is also referred to as a variance. And I believe that you know that when you find the square root of the variance, we get the standard deviation. And so this is how we're going to compute the standard deviation. We'll start from the mean deviation, which simply looks at how each value moves away from the middle. So if it is the mean, then how is each value different from the mean? So we do each observation minus the mean for the mean deviation. So by formulas, mean deviation is just going to be the summation of each observation. So we're going to have each observation, for instance, x minus x bar, because x bar is the mean, and then x is the individual observation divided by n. And this is for ungrouped data. When you want to compute the mean absolute deviation, the formula changes. We use the absolute terms, so we go by the summation of the absolute x minus x bar over the n. And then if you want to do the mean squared deviation, we're going to have the summation of x minus x bar, this time squared, over the n in that particular order. So these are the formulas. Let's start with the mean deviation and how we can apply. And we're going to look at it from the ungrouped data and the group data point of view. So for ungrouped data, if you want to find the mean deviation of these values, we first have to compute the mean, because the formula has the mean. And how do we compute the mean? Any idea? Any idea on how to compute the mean? If you have this observation, how do you compute the mean?
Is the summation of n over n. We sum
Okay,
all.
so the summation of all the
Yeah.
yeah. So Prince, do that for us.
Okay. So we will add 4 to 7 to give us 11, to give us 17, plus 10 to give us 27, and plus 8 to give us 35, all divided by 5.
So our mean will be.
So the answer is yes, so it's 7.
The answer is
7.
okay.
7.
So once we get the mean, then we come and apply this formula, which is the mean deviation formula. It says that we should take each observation from the mean. So the first observation is 4 minus 7. Then the summation sign is what we are seeing as the plus here. So plus, then we go to the next observation, which is 7 minus the mean of 7. Then we bring our summation sign again. Then we go for the next one, which is 6 minus 7, plus 10 minus 7, and then finally 8 minus 7. Normally, when you calculate the mean deviation, your answer normally approaches 0. And so when you want to measure for dispersion, we usually say the mean deviation is not the appropriate because mostly the resource is 0. And that is why the mean absolute was introduced. So we can try the mean absolute from here. The same question, when we want to compute the mean absolute deviation, we are saying that we are going to go for the summation of now the absolute term x minus x bar over n. So let's use the same approach to compute. Now the x absolute here that we are seeing simply means that, for example, when you do 4 minus 7 here, the answer is negative 3. But when you are considering the mean absolute deviation, the negative will be considered as positive. So it is the same thing, but now we are writing it in block terms. So when we do so, we're now going to have 4 minus 7 in block plus 7 minus 7 in block, which means that every negative answer will be considered as positive. And then we sum them up and divide it by 5. So let's simplify that one quickly. My ladies, I hope you are with me.
Yes, sir.
Any answer? Or you are still working?
Yes.
I tried with my head. I don't know. I'm not having any calculators, but I had 1.6.
1.6.
Like, yes.
Okay,
I'm not having anything. I'm not having anything to calculate, so I guess use my head.
that's fine. Any confirmation?
I had negative 1.2.
Negative.
Yeah.
You said you are not working with negatives.
Okay.
So
Okay.
it means that when we have this one will be 3 plus.
Like the first
So
one.
we just following the first one.
Yeah.
This
Okay.
one will
So
be 3 plus 0 plus 1
1
plus
plus 3
3
plus
plus
1.
1.
So it will
Everything
be
divided by 5. So we
it will be 8
have
divided by 5.
8
8.
divided by 5, which is
So give us
1.6.
6.
Oh, okay, so we just have to ignore the negative.
Exactly.
Okay.
That's what.
Yeah, so let's do same for the mean square deviation. With the mean square deviation, we're now going to follow the same approach. But this time we're going to square the values we have here. So we're going to have the square here, in that particular order. So this one, we are going to rely on the negatives. However, we will square each item in the bracket. We will square each item in the bracket. So in this case, we're going to have negative 3 square plus 0
square
plus 1 square plus 3 square plus 1 square over 5. And then going to be 9 plus 0 is 1 plus 9 plus 1 over 5.
So the answer will be 4.
Okay.
4.
We're going to have 20 divided by 5, which is 4.
Yeah.
Yes. So the mean square deviation, again, we said is the same as the variance. The same as the variance. And when you want to find the standard deviation, we do the square root of the mean squared deviation, which is equal to the square root of 4, giving us what? 2.
2. Yeah.
Yeah. Julie, is it okay?
Yes, sir.
And then Alice, are you on?
Yes, sir, I'm on.
Augustina. Okay. So this is for the ungrouped data. Now, let's look at how the formulas will change when we have the group data. You realize that the group data comes with the frequency. So for the mean square deviation, you can introduce the frequency just like we have here. There is a absolute mean deviation. We will just have the frequency in here, and it is just this formula that have been converted to this. So the difference are not much. We only introduce the frequency in there, and that is what makes the difference. Similarly, when we come to the variance or the mean square deviation, this is for the ungrouped data, and this is for the group. And so the group is either we just introduce a frequency to this one, like we have in here. So this first formula is similar to the one here, but we've introduced a frequency and then we've changed the n to the summation of the frequency. Or we can go by this other formula, the summation of fx squared. And that is why the early table that we saw, you realize that there was x squared, and then there was that particular, this one. The table went for the s squared, and then it came for the fx squared. So normally when you are given a question that will require you to compute all of that, then it means that your table should be extended to cover all the other items that you will need to solve that particular question. So this is the mean absolute deviation. And then there is the mean squared deviation. In other words, how you get the variance. And then for ungrouped data, the standard deviation is the square root of the mean square deviation. So this formula here, when you find the square root, you get the standard deviation. And then for the one here, when you find the standard deviation, it also gives you, when you find the square root of any of these two formulas, it also gives you the standard deviation. Now, what I want you to pay key attention to is the terms that are associated with the standard deviation, the variance, and the rest. So for the variance, it is measuring the risk, while the standard deviation is an appropriate measure of risk. And so the variance and the standard deviation are all measuring the risk, but the standard deviation is preferred to the variance. Now, the mean absolute deviation is talking about reliability, and then also the mean deviation.
Sir, please, I went off. Could you repeat that again, please?
Yes, so the mean deviation is just helping us to know that especially how it moves away. The mean absolute deviation is looking at the reliability, and then the variance is looking at the risk measurement, whereas the standard deviation is an appropriate measure of risk as compared to the variance. We have other relative measure, which we can talk about the coefficient of variation and the rest. So there are lots of things. I'm going to share the slides with you, and I want you to go through them. Wherever you get to any issues that you get out of it, you draw my attention, then we discuss them. And I want you to go through this particular illustration, which says that the following frequency distribution represents the times over 1 week period that patients had to wait before seeing a doctor at the emergency department of 2 hospitals, A and B. So you have to determine the mean waiting time for each hospital. The mean waiting time here, it means that you are just to compute the mean of hospital A and hospital B. Then the second part says that determine which of the hospital will reliably meet the waiting expectation of patients. Reliably. And that is where I told you that when you are solving, the mean absolute deviation is a measure of reliability. So the question is just asking you to compute the mean absolute deviation. You go through the same things. The next question says that based on the average waiting time, determine the appropriate measure of risk. Remember, the appropriate measure of risk, we said it is the standard deviation. The standard deviation is the appropriate measure of risk. Because we also said that the variance measure risk, but the most appropriate is the standard deviation. So B is asking us to compute the mean absolute deviation. The C is asking us to compute the standard deviation. Then D is asking which of the hospitals is safer for patients with emergency cases. Which of the hospitals is safer? Here you have to compute the coefficient of variation. The coefficient of variation says that after getting your mean and your standard deviation, you do that one. And that is what we mean by the relative risk. It compares the risk of 2 sets. So whenever you want to compare 2 given sets, you use the coefficient of variation. And so the illustration is going to cover all of these activities. Then we also finally determine the measure of skewness. Remember the skewness, we use this formula or this other formula. After getting your mean, median, and then the standard deviation. So this is just an illustration to awaken your understanding on all that we have done today. So we are going to go through this question at your leisure. Just be able to compute the mean, the median, and the mode, and then compute the mean absolute deviation. You also compute the variance which leads to the standard deviation. Then you go ahead to compute the coefficient of variation, and then you are able to conclude on the questions that have been asked. Let me be reminding you that this is just a past question. This is a past question that came, I think, last year or last 2 years. So just try your hands and then work as faster as you can to be able to answer all the questions. The solution is also attached anyway, but I want you to go through and then you compare your answers to the solution. And then there are other try questions here that I want you to go through. Any question before we close? Any question?
Please, in the previous lecture, since you gave assignment, is it for collection or for us to try our hands on?
No, the first assignment I gave you concerning the questionnaire, I'll take it. Is that the one you are asking?
Yes, please.
Yes, that one I will take it. I told you I'll communicate through the rep who will share on your page on the means of submission.
Okay.
Any other concern? Hello.
Hello, sir.
Yes, madam.
Oh. Okay, so sir, we will try our hands on it. So if there is any question, we'll put them down and we'll communicate with you or when we meet.
No problem. If there is any confusion, any question, you just draw my attention. You can send me a WhatsApp message and I will respond.
Okay. Thank you.
You're welcome. Any other concern? Okay. So if there is no concern, then you pause here. I'll share the slides with you through the rep and then we meet next week. Next week, we're going to look at correlation and regression. Then if there is time, you will start with the differentiation concepts. Well, so let's eat before we meet next week.
Of course. Thank you, sir.
All right. Have a nice evening.
Thanks, and same to you.
Same to you, sir. Bye.
Thank you. Hello, Danny.
Please, there are many Daniels here. Which one are you referring to?
Daniel Minta.
Yes, please, I'm here.
Okay. Whilst I think Say is going to, I think those who are here, whether we can discuss one or two things. Last week we wanted to see whether we can within the week we can have a personal group meeting so that we discuss some of these questions, and then since the time we have is limited. But up to now, I think course rep placed something on the platform and no one responded. So I don't
sorry,
know.
I haven't seen it. Maybe I'm yet to respond.
So that we can, at least we should have, that was my suggestion. And then I think Auntie Rita also said something like that, so that we can have a day within the week and do our prepping, since all of us are very busy. And last week we also discussed that. I don't know your center then. Most of the centers, we don't meet ourselves. Me at my center, it's only I who do accounting there. And I don't know most of the centers there. So at least if we equipped ourselves very well and we go, I think it will help. So if there's anything, then we discuss and fix the date and then discuss about it. I don't know.
I think it's a good idea. So, do you want us to discuss the days here or on the platform?
Since the lecture is out, we can discuss the days here, and then we move forward. Since the days are limited, I think we have only 3 meetings for us to go write our quiz and others.
Okay. Yeah, it's true.
Hello, Uncle Daniel.
Yes, please.
Yes, I saw you. So please let's contribute. Since as far as we the ladies, we are here. You the men, you have, because today I'm a little bit confused when I'm going. Then I start at a place and so that we discuss in the paper ourselves very well, especially with all these formulas. It should be in our heads. Go.
Yeah.